Hello again, everybody. Welcome to another episode of GeoStrata Extra. You have found us. This is our second one of the year. We are very excited today to have George Koerner of the Geosynthetics Institute with us to talk about his piece from the March-April GeoStrata Geosynthetics for the Common Good. If you do not know anything about the Geo-Institute, or you only know a very little, we are a technical society for geotechnical engineers and geologists that is part of the American Society of Civil Engineers. We have about 12,000 members. We do a lot of great stuff. Technical committees, conferences, you can check it all out at geo-institute.org. If you are new to our YouTube channel and you like what you are about to see, and I hope you do, click on the little button outside the window you're watching this in that says subscribe, then click get notifications. We will let you know every single time we post a new video to the channel, which is frequently. So that is my introduction. Now we will get to the meat and potatoes. Our interviewer today from Lafayette College and an editor of GeoStrata magazine is Mike McGuire. Mike, take it away.
All right. I feel like I'm being introduced for a fight. All right. Thank you very much, Brad. I'm very happy to be doing this today with Dr. Koerner. As Brad mentioned, the theme today is talking about the commentary, Geosynthetics for the Common Good, authored by George Koerner, that's going to be appearing in the latest issue of GeoStrata magazine. If you don't have your physical copy yet, you can get it online. Got a bunch of really interesting discussion in front of us. I do want to thank our sponsor for today's session, Aero Aggregates. If you don't know anything about Aero Aggregates, it's a really fantastic lightweight material made from recycled glass, and they've got great folks down there, so definitely check them out. Dr. George Koerner. So I've known George for many years. Both George and I are from Delaware County, Pennsylvania. Both of us did some schooling in the Philadelphia area. George, your background with geosynthetics goes back as far as humanly possible, right? You basically have been brought up both formally, with an academic background in geosynthetics, but geosynthetics runs in your blood as well. So doing your undergraduate and graduate work at Drexel, which is the same institution that your father, Bob, taught at. After graduating, you worked a bit at Schnabel Foundation, and then you've been with the Geosynthetics Institute as director since 2014. I've got, let's see, a couple questions prepared, but also if you have any questions as you're watching this interview that you have, feel free to put them in the chat. Brad will be monitoring the chat as we go through, and we'll be looking to spot those questions as we go. To get started, I want to just ask you, George, what is the Geosynthetics Institute? Can you tell us a little bit about that organization?
Dr. McGuire, thank you so much. It's just a privilege to be here. GSI is a nonprofit. It's a 501c3 incorporated in Delaware in '93. Its mission truly is to develop and transfer knowledge about geosynthetics, assess and critique these materials, not always good, bad, lumps and warts, everything in there, and also provide services to the members. The umbrella organization is GSI, and it has 5 different institutes underneath it: research, accreditation, information, certification, and education. Capabilities, we're small. We only have 4 to 8 people here. During the summertime, we get a bunch of co-ops in to do the lab work. We pride ourselves on being able to do design, field work, lab work, all about geosynthetics. Please check out our website and our YouTube videos. It's an honor to be with you. I've known you for a while and think the world of you. You're just a great guy to work with. So
Great.
ask away. I'll try.
Great. So I want to get right into some of the interesting points you raised in your commentary. And one of the things that is still with us is this question about durability, right? And so back when plastics came onto the scene in the 20th century, we started using them for single-use beverage containers, and we have this great problem now with plastic waste. But a lot of people's perception about plastic is it's temporary, right? And this, we can't possibly design for the long term using plastic. And this was an issue that your father, through a lot of his career, worked really hard to provide evidence to overcome this stigma. And so my question to you is, has this issue of durability, has this been put to rest? Or are there still claims out there, whether founded or unfounded, about the durability of high-quality geosynthetics?
It's an important issue, and it's as important as physical, mechanical, or hydraulic properties. This issue with durability is paramount when talking about an engineered material. And to answer your question directly, it will never be answered. The polymers are unique enough that each one will need to be investigated. And this is a two-prong approach that needs to occur with this. We'll do laboratory testing, maybe Arrhenius modeling, a simulation, and then we'll take case histories from the field, learn all the time, improve all the time. The formulations have gotten better, and the materials are performing fabulously. Mm-hmm. There are ever-changing environmental conditions and ever new applications. So the durability constraints will always be, and I think, ratcheted up. It's an opportunity, and I think I'll still be writing about durability. I just signed on for another 3 years at ASTM. I'll chair the D35 committee 02 on durability for the next couple of years. Eric Blond is handing it down to me again. So
nice.
Yeah.
And not to single out any manufacturers, but there's some manufacturers that have been around for quite some time and have a proven track record, but there's other manufacturers that are entering the market. Are there any new concerns about new players entering the market, or are these newer manufacturers, certainly they're entering in good faith, but are they entering kind of having worked out all the bugs in terms of their products?
Oh, beautiful question. First of all, there's a cost associated with everything. And this is a competitive industry. And if you can find a better way to make the widget with less cost, classic example is some firms will introduce calcium carbonate into a polymer. Now, you have it will improve some properties, but everything is a balancing act. So the second part in response to your question is you can learn a lot from the past, and there's a lot in the literature. These companies that are entering the market are benefited by being second. You can learn quite a bit, but you need to get the right people and get the right team together to communicate openly about this and certainly make it last a long time. These are engineered materials. These are not commodity plastics.
Right. So another thing that you talk about that I think is a good bridge to what we were just discussing is that as confidence in these materials has really become mainstream, that there are ways that geosynthetics can be used as part of a push towards more sustainable infrastructure. And so there's I think GSI has come out and said that geosynthetics are part of a sustainable future. Certainly the manufacturers have kind of put this forward. What is the best evidence for this? What is the best evidence that you could point somebody to that geosynthetics are in fact consistent with a more sustainable infrastructure?
Yeah, I hear this from two different approaches, of qualitative approach and a quantitative approach. I much rather the quantitative approach of embedded carbon calculation. If you're in this line of work or this foray, I would certainly put you to the RAP report from the UK on civil engineering products that would guide you in that regard. We have a lot of evidence in this regard from 3 white papers, which are on our website. White paper 2 is benefit cost. 41 is geosynthetics and waste from a sustainability perspective. And 44 is geosynthetics and roads from a sustainability perspective. The geosynthetic alternative looks quite promising compared to traditional materials. This discussion of a natural equivalent to geosynthetics is there sometimes are not. These are, I wouldn't say new materials. They've been around some as many as 50 years, but they can do things that traditional concrete soils can't.
Right. And I mean, it's not that those materials have no cost to the environment as well, right? You know, so I think every material has its strengths and its weaknesses in that regard.
And they can complement one another too.
Exactly.
Which is kind of neat, especially from a geotechnical perspective. I am not a polymer engineer. I'm a geotech at first.
Right. So, you know, we're on the cusp of April, right? April's Earth Month, right? Earth Days at the end of April, and so we're thinking more about the environment, and we just talked about sustainability, and so there's, I think, some good things on the horizon with respect to, I think, more renewed attention in kind of public policy with respect to sustainability. One thing that has come back into the forefront, it's never really left, but I think there's been even some recent mainstream media stories on this, is the problem we have with plastics. What happens to plastics over their life cycle? And so geosynthetics, being polymer based, have some association with the plastic problem, right? So there's some tie to the fossil fuel industry, which is often maligned. And so how do you see geosynthetics? How do you respond to criticisms about geosynthetics being a plastic material?
First of all, this is very warranted. This is a valuable conversation. Any geosynthetic has to provide a fitness of use for any construction site. This is carried on now through AASHTO, NTPEP, Datamine, Caltrans, all have this. They are specifically asking what risks to human health and the environment does any construction material have? And that's a replete across all the different materials. And please realize the path to quality starts with most of these geosynthetics in the actual formulation. They're asking questions about this on a regular basis. These suppliers are committed. There's customer service as well as technical people to support these questions for the specific application. They also conform to pretty rigorous international standards, which is kind of neat. Realize also that geosynthetics are tools in a toolbox, so to speak. There are many alternatives. And a neat thing about geosynthetics, they're often a catalyst for the natural environment to take hold. High performance turf reinforcement mats, filters, things like that, all geosynthetic, encourage the natural system to take over and behave in a controlled condition.
Yeah. Where's the industry with the use of recycled content in geosynthetics? It seems like it's possible. I've seen I know there are some products out there, but I'm not sure that right now geosynthetics with high recycled content are readily available as much as those that don't.
This is a balancing act, like most things in life. It's a push-pull between durability and recycled content.
Mm-hmm.
For instance, polyester. You can reconstitute polyester down to its principal parts and spin it. Soda bottles are medical grade polyester, which have been made into polyester geotextiles by Wellman Q Line.
Mm-hmm.
There are, Carlisle has a huge facility to remold plastics into this block configuration, which acts as a drain board. You mentioned aero aggregates with glass, hemp, jute. All these can be incorporated into different materials, but the durability question, are the materials compromised, particularly when you're getting onto the 50 to 100 to 200 year perspective? It's tough to add those materials in there and demand those durability numbers.
Yeah. So it's kind of jumping off of that. I mean, certainly there's a lot of permanent applications that we need to have that 125 year design life, but there's also some applications that, temporary applications where we don't need as long of a design life, or where the consequences of some degradation of the, say it's soil reinforcement, for example, that's acceptable. There's been some recent uptick in research on using plant fiber based reinforcing material, such as using hemp, which is a material that goes back very, very, it's actually the original, some of the original reinforcing material out there. Do you see plant-based fibers or polymers derived from plants? Is that under the umbrella of geosynthetics? And if so, how do you see those products fitting in?
Yes is the answer. That is a geosynthetics. One of the nicest things is that it will absorb water, so it provides a nice vegetation root mat. So you're in the money, so to speak, with that. Can you incorporate it with a polymer to make it stronger? Certainly. Can you monitor it to know when it's degrading, and then go after it again? This is a big discussion, to set a design life to something and then subsequently go in and rehab it. You've had a savings, a window, so to speak, that you designed for, and then you can go after it. They're also they're incorporating starch in some of the materials so that they would degrade on time. So but you need a monitoring component with that, which is neat research.
I see future intersections between geosynthetics and biogeotechnics, for example. There you have people looking at roots directly, the actual root or things inspired by roots. And so this, what you're saying, it sounds like there could be some very interesting directions that plant-based materials may go in the future.
Or actually a filter and clog it on purpose to make a liner out of it.
Yeah.
Send a polymer down there to interact with a certain mineral to shut things off and make a complete filter cake. All sorts of things.
Like when you're happy that there's bioclogging. Nice. While we're on the topic of kind of the future, we're also looking at a future, a more electrified future, and also a more battery intensive future, right? And so our best technology right now for chemical storage of energy is a lithium based battery. That may change in the future, but it looks like lithium's going to be in demand for a while. And the magazine has the March-April issue of GeoStrata has a very nice article about lithium mining, these large evaporation ponds where you put brine salts and you use the sun to drive off the water, and you can harvest those brine salts and extract lithium. How do you see, besides just these evaporation ponds, or just maybe just talking more about these evaporation ponds, how do you see geosynthetics enabling or assisting in this transition from kind of a more fossil fuel intensive economy to a more electrified economy?
For instance, lithium mining used to be hard rock mining, not more than 15 years ago. Now it's all geothermal and brine driven in cascading ponds. You get a pregnant solution, and this pregnant solution, then you have to extract the material from it. And this is done through filtration, a lot of drainage materials used, as well as filters. You have materials in regard to geotextile tubes, which are used in that application. Managing this effectively and on the scale at which these are not, we're not several acres, we're 100 acres or even more than that in scale and in size. The efficiencies from this are for the people in the future. Our demand is only going to increase with ever increasing population. I see it as fantastic opportunity for, and I can envision not just containment, but a lot of use of geosynthetics in that entire process.
Yeah, no, I mean, it seems like we've pretty much pointed the ship towards, really promoting, say, electrified vehicles or home battery systems, and lithium batteries are it. And there's really not much discussion about mass producing any other alternative at this point. So as you described, it seems like it's just a tremendous opportunity for geosynthetics to enable this. So this, in a way, I mean, it is. It's a mining application of geosynthetics, but it's not.
I have to back you up a little bit.
Oh, okay.
There's so much renewable energy with geosynthetics. Also, in addition to all that, solar, flexor, rigid, on cover system, exposed geomembrane cover. These algae bags out in the San Francisco Bay, that with the creating the fuel. Cogeneration facilities at landfills, construction platforms for wind. And it's so nice. It integrates these older systems and new systems. And right. It could really, the geosynthetics are really a bridge between them. And it can be an and. It doesn't have to be if or. It truly can be an and to that. So sorry to interrupt you, but
no. Very thank you for that. I mean, just even accessing these sites. I mean, if you're creating a new wind farm and you want to be, a lot of these wind farms are being constructed in environmentally sensitive areas, and just getting a light footprint road in.
Let alone a Nissan rig to set down deep foundations for that rascal. It's
Right. Yeah. So, but kind of a little more on mining. So this isn't lithium extraction isn't the only way that geosynthetics are used in mining. A couple of things that come to my mind are there's been a huge growth in heap leach mining, and there's increased talk about even landfill mining. That there's a lot of potentially valuable materials, metals in landfill, and there's going to be some tipping point at which point that becomes economical. And so our knowledge about leachate collection systems, which is fairly robust and mature at this point, we have this kind of new twist where our objectives are slightly different. What are you hearing about this, the future of geosynthetics in mining?
It's sky's the limit. Let's go one by one, your questions. Heap leach, extracting these metals from, and it can be precious metals as well as, copper or nickel, but to take a couple hundred acres and drip cyanide through an ore and collect it in a pond, that was unheard of 20 years, 30 years ago. And it's the norm now. And it's done at such a scale. And it's not just, it's on it's on 4 continents, I guess, in rather outrageously large form. If you look at the phosphate gypsum mining in Florida, wow, just the scale of this, the size of those facilities and the engineering that goes involved in it. I was so happy when Delaware Solid Waste won Project of the Year. I could tell all my friends, my brother and my sister, one's an electrical, one's we won Project of the Year. The civils, got it sort of stuff. There was enough technology, but there's an amazing amount of technology on the West Coast. I not only mining the waste, but mining the energy, the thermal inside of it, and getting the energy side of things, which is great. You didn't talk about oil and gas, but geosynthetics are, we know the Marcellus regions here, which is tremendous. And then I'll go even the backside, the waste side of things, coal combustion residual with the federal regulations over the last 3 years. That's a massive driver down in the Southeast and through the entire center prong of the United States. So mining is just, geosynthetics are replete in it. And I won't get so confident that it's will keep being the driver that it is. We have seen fluctuations in it. We all remember 2008 sort of thing, but it can go away. But if the population keeps increasing and the need for it is there, that's it. Yeah.
It's interesting how I imagine that where, you think of like membranes, like who's buying membranes and when landfills were a big purchaser of membranes, and now, maybe more of the membranes are going into the mining sector now. Would you say that
no baby associated with that?
Yeah. So kind of speaking of supply and demand, 2020 was a pretty crazy year, right? And with COVID, what was the impact of COVID on the geosynthetics kind of the manufacturing of and the consumption of geosynthetics? What's going to go in the history books there?
I think the demand is still very high, and the supply is tough, is very hard right now. There's even force majeure letters that have gone out for several olefin manufacturers, both polypropylene and polyethylene. The contractors are, I would not like to be an installation contractor. It's hard. How do you go back to an owner and you would have to relinquish your bond on this? It's difficult. You can see all the previous administration, a lot of international manufacturers came to the United States and built plants here due to the fear of losing out on that business. Ingenious people. My hat's off to the manufacturers. They are the true risk takers in this. And but you present them with a challenge, and they can come up with some pretty nice products. You have to say though, we have to check one another. Everybody's better when they're checked, and we should go through that.
What were or are the choke points on the supply side? Is it just borders being things moving across borders being limited, or what are the major choke points?
Shipping and handling, weather, people make excuses. I don't know. We can talk an hour on this. I don't know what's hearsay and what's real. You would have to get to the underbelly of it. But boy, if we could sit and talk about that, I would like to get to the bottom of it. But I can tell you, demand is high and supply is not great right now.
Yeah, and
with a lot of big owners inventorying tremendous amount of material.
Oh, I
So
see.
that's a different dynamic, you know, especially when you need a couple rolls delivered. You are in the back of the line, so to speak.
So
It's
it's kind of like how I have 20 rolls of paper towels in my basement.
pretty much, but
Yeah.
scale that would.
So, like, is there optimism, or if we had a manufacturer, sitting down with us right now, would they be saying, yeah, 2021, we see things clearing up, or is this going to be a protracted recovery on the supply side?
I haven't seen resin plants come online. You have to realize that's a tremendous investment. I'm really waiting for the olefin plant in Pittsburgh from the shale gas to come online. That's a huge investment. But we're not, this is business. This is we're not wimps. Somebody's going to figure this out. This is not, you don't have that imbalance for too long. Gosh, we've got this. The wind's at our back, and our sails are not quite totally full, but it's nice.
There's reason to be hopeful.
Yep.
So hey, we got a couple questions coming in on the chat, and a couple good ones here. So I wanted to kind of steer our discussion that direction. Question here coming in about the future of geosynthetics in the agricultural sector. I don't think we've really touched on that yet. What are some of the things that you're seeing, kind of with emphasis on the new innovative ways that geosynthetics are supporting agriculture?
Agriculture and aquaculture, huge benefits. All this farming of fish and things like that, also with the netting is involved with it. Very interested in that risk to the environment now. And we really want durability, and durability, exposed durability, UV. New things with irrigation, new things with pest control, new things with embedding iodine and fungicides in materials in the ground that are EPA approved, but different state to state regulation. Greenhouse films. If you go to Colombia, you'll see roses grown just amazing with different films with different UV spectra light letting in.
Oh, wow.
And it's fantastic. It just really sky's the limit, and a lot of technology into it, which is good to see.
It seems like with geosynthetics, the ability for a manufacturer to respond to a need is fairly short, relative to other manufactured materials. Would you say that if someone says, hey, I want to do X, Y, Z, as long as that's within the constraints of things that are achievable in manufacturing, it seems like manufacturers can turn that around pretty quickly. Is that?
And I wonder if it's patentable. So you can't protect what you've. That's the business side of things. We saw that with spider netting and things like that. The technology just morphs into so many different things. You can't. It's the nature of the business, but it's as true as can be. You can spot an idea, you can see it and reverse engineer it so quick. It's.
Yeah. So our commentator, so this is Logan Markley, who asked the first question. Asked another question, which is really good. I'm going to pose right now. And this is about the use of geosynthetics in water recycling. So maybe not so much of a need for us on the East Coast, but in the kind of more water scarce West, they're really having to be innovative on kind of stretching available water. So how are you seeing geosynthetics being used in innovative ways with respect to water recycling?
Everything from the filtration to stopping evapotranspiration. nice projects by the Bureau of Reclamation trying to put floating covers on canals. I've seen large bag in the island of Cyprus moving potable water with a tug into Cyprus with large bags, not big containers.
Yeah.
I call it a geosynthetic, but it's not it's hydrosynthetic.
It's like
hydropower.
You ever go hiking with those camelback bladders?
Yes.
It's like the largest camelback bladder ever envisioned.
The whale would nudge up to it and probably feel small, but neat things. Sky's the limit, just to get this and to use the resource wisely. I hear over and over through ASCE that water will be it going forward. I'm not out west. We have sometimes too much water here in the Northeast. We've experienced the 100-year flood 3 times in the last 10 years. Yeah. They've rezoned GSI into the floodplain. So, we have the opposite problem, I guess.
Yeah. Another question, this is coming in from Roya, and this is about thermal resistance of geosynthetics. So I think the root of the question is getting at that if we're using geosynthetics increasingly in extreme climates, whether it's very hot or extremely cold, or if you have an environment where you have large temperature swings, are there particular considerations with respect to thermal resistance?
Tremendous. Great question. First of all, in the initial stages of the material, there's typically a processing aid, and then there's an AO package to stop degradation. But then later on during its life, you're looking at perhaps a hydroamine light stabilizer to stop it from degrading. What you're very interested, they're describing a thermal swing, this thermal coefficient of expansion and contraction. And to that, you can get a right polymer, a right formulation, or you could scrim reinforce the material to stop it from moving around. This concept is very important with intimate contact between a membrane and underlying GCl or CCl. So great question. A lot of research in this, and have a new, I'm trying to get a new standard through ASTM on that exact thing. We wrote a GRI standard on it. If you want to work with me in D35, it would be great.
And associated with your response on the thermal resistance, with these temperature swings, you can also get large swings in near surface soil moisture. Is that something that you mentioned GCLs are there things happening with increasing kind of the resistance to large swings in moisture content?
Oh, yes. And different products coming in. You can encapsulate it. You can use different textiles. You can use different infills. You can place a drain below it. The world's your oyster in a very thin cross section too. It's whatever you can think of. They're doing reverse Gore-Tex for geosynthetics. So think about that. You're holding water, but you're passing gas. It's really it's just wow.
Yeah.
The future. I don't know if a young person is watching, but if you're a student, you really, gosh, if you had a combination of engineering and polymers.
It's interesting. Last week you did a hike of a section of the Appalachian Trail, and for this session we were chatting about hiking a bit. And it's interesting to think about this interplay between technical fabrics in the automotive and consumer sectors, and then in the kind of industrial geosynthetic sector. I'm thinking, wow, if like Gore-Tex becomes manufactured at larger scale, maybe I can get I can afford to get some.
So, Mike, I was holding back. I was holding back from you. I I really think in two different worlds, the built world and sort of the natural world. And I like to escape to the natural world often.
Mm-hmm.
But I'm coming in there to Waynesboro on Route 16. And sure enough, not 2 blocks from the start of my hike, I see a presto wall on 1-to-1 slope used as erosion control. I exit 43 miles down the road, and the bridge into Harper's Ferry has Trex polymeric material all the way across for the woodwork. I can't get away from geosynthetics.
Yeah.
It's amazing.
It's a good thing you like it, or it could drive you nuts.
But I talked to my family all about it, and they're all in it, so it's cool. It worked out.
Got another question from Roya, which is I think it's an interesting question. When you talk about like levee infrastructure, there's a lot of very serious research on the impact of animal burrows on impacting levees, and so Roya's question is about animal damage to geosynthetics, and that there's animals like to nibble on things, and is there? I mean, again, can you kind of paint a picture of how big that problem is, and what the industry is doing to address the problems of animals?
This is real. This is that biologic component is not from microorganisms eating, but actual mammals or having their way with a turf reinforcement, getting into it and getting caught. This relationship between biology, which a larger biology, and geosynthetics is real and will need to be addressed. People that have done excellent work on this are the Dutch. They're very humane about it. They have 3 guides, papers in this regard. I had the privilege of going down to Cherry Island for the review of the big wall on the landfill down there. And sure enough, when I scaled the wall, didn't a muskrat come out from me? He had burrowed straight in through the green wall, right through the turf reinforcement mat. This is very real. The Corps of Engineers has documents on this, and striking this balance is going to be important going forward. And it gets as big as a moose going down into a surface impoundment, or, a membrane doesn't have a chance next to an animal's hoof that size. So great question. And yes, we'll have to be reconciled with going forward.
Are there things that manufacturers have done to make geosynthetics less attractive to animals, like adding, you can add like agents that taste bitter, for example, or I don't know, something that, is there an animal behavior psychologist on, consulting with these manufacturers to try to discourage negative interactions?
Of them. Iodine is your winner in that regard. It's patented by several. Also, color freaks them out. There's some colors that they stay away from. There are smells, but it becomes transient. And then you say to yourself, I'm doing no risk to the environment. So now you have to do a TCLP or something on that to make sure that it's fast and locked. So yes, they go after the senses, so to speak, and try to and also make something else more attractive.
Okay.
Is the other redundant
so it's like
thing to
don't look at this, look at this. I mean, instead, kind of thing.
Or also gravel, for instance, is a deterrent to most rodents, and to superimpose that. If you go to Rocky Mountain Nuclear Arsenal, you'll see a cover made of textile with gravel incorporated into it, and that's their liner system. So, great questions.
Interesting. Yeah, I see some academic researcher brains going here. I'm like, man, this could be some really interesting collaborations. You get some biologists sitting down with some civil engineers and some polymer chemists. You could have quite the party. Yeah. Let's see. Let's talk a little bit about infrastructure. So we've got a new administration. And so that means, the chatter about infrastructure spending and infrastructure bill, that's become renewed. And, I'm hoping that this may be the time we do get an infrastructure package through. What would that mean for geosynthetics if we had a really meaningful infrastructure spending bill? What would be the applications that would really stand out as requiring a lot of support from the geosynthetics industry?
Pavements, highways would have to be on the top of my list. That's big from a transportation perspective, geotechnical perspective. Walls, slopes, and embankments would tailor on with that, but highway and pavement will just go through the roof. That's on every radar. Imaginal. So that would certainly be it.
Are there any surprises? I mean, because I think pavements was the first one that came to my mind. Are there any other potential winners that may be a little less kind of glaring if we do get some large infrastructure spending?
I just had one last week that just blew me away. I didn't realize all the sed basins have to be isolated.
Oh.
So you're putting membranes now in a sed basin with fluctuating water. So you're going to have to anchor the membranes and then control release the water.
Yeah.
Oh, you'll be putting burritos. You'll be putting ankles down. I mean, it's really complicated. But we have one over in Jersey that's going to be submerged 8 feet. It's like, wow, that's a design. I mean, you're think of the hydrostatic uplift on this thing and how you can't have it blow out every week. So yeah, just great opportunities. I never knew. I never realized it.
Interesting. Yes. We got a question from Lilma Schimmel, who both of us know. And so she's representing the designer manufacturer side, and kind of from her perspective, she sees the growth of opportunity sort of exceeding the ability for us to almost keep up in innovation. Do you agree with that, or do you think that we're able to, as opportunities and ideas pop up, are we able to?
She's sandbagging us. This is not right. I know her well. She has more talent than. Oh no, she can. Yeah. Don't give me a break. No, she is fantastic. She will find out once the opportunities present themselves. They have it. Shoot, and she works for a massive German company that we know that well.
Maybe she was winking when she asked this question. It didn't come through on the chat, but
I tell you, I'll be down in Charlotte soon. I'll see them again. Oh, Loma, how are you? I hope you're well.
Yes, yeah. I think we've just spent like the last half hour talking about how fast the geosynthetics industry is able to kind of adapt and provide solutions.
Like an amoeba. It just what do you want? You have to be very specific on what you want.
Right.
But it's really yes is the reply to it.
Yeah. So also getting back to your commentary. So you talk about not just going out and throwing geosynthetics in the ground. That we have to have a practiced, formalized systems approach, right? And you cite a very early EPA document that has some bullet points that kind of lay out this systems approach to designing with geosynthetics. And the first bullet point, I'll just read this verbatim: good design by a professional engineer trained in geosynthetics, right? So there's a lot here, right? That we can't just have someone who is not trained go into a catalog, pick a geosynthetic and say, yep, we're going to use that in this application. So with that said, the fact that we have somebody who's a professional engineer, someone who's trained, and we're providing, we're doing things carefully. Do you see in some applications, maybe excessive conservatism in our design? And if so, can you talk a little bit about what that application may be?
I wish you would have asked me it the other way around, because then
Okay.
I could tell you the failures and that sort of stuff. But thinking about this, and I was just on the phone with JP Giroux yesterday, so he's gonna come over here from France and get me. But filtration, and there are people that know this. The first blush of fines going through that geosynthetic that's trying to make a filter cake.
Mm-hmm.
If you could manage that first blush of passing the number 200, you could get like a cesspool where to deposit it and not have to deal with it. Then your filter designs could be much more open, and then they would flow much better over time. So you'd build in, but you have to manage that. Thinking about it, I've seen that a couple different ways. A guy out at CTI in Michigan, Tiang Sung, who wrote very nicely about my dad in GeoStrata. He has that for sumps, like a recirculating sump. And Kerry Petrasic, who used to work for PennDOT, he did it with edge drains, using big monofilaments, but he could discharge the fines. But yeah, I'm going against convention here. I just went around, soil retention versus piping. I'm arrowing on the side of piping, but if you could manage that first blush, don't do it over top of a geocomposite drainage layer, but that would be the area where I think we could.
We could maybe back off just slightly if we're smart about it.
There's fat on there that somebody could, a design consultant could really add to the owner. And it'd be not only a performance benefit, but might have a cost benefit too. So
yeah, it would seem so. Yeah. So I want to continue to unpack this first bullet. All right. So you say the last bit is trained in geosynthetics. So as an educator, I have to have an education related question. In your opinion, how do you feel that we educators, the industry, organizations like GSI, how are we doing in training undergraduates and graduate students in the field of geosynthetics?
I can tell you the last 10 years, I am thoroughly impressed with the people that have come through here. We have student night here at GSI, and the students are talented. They're talented, multi-fast in the way we go. The next component to this is I never thought I was a virtual person, but this is really great. How can we be touching, you're touching 100 people at lunchtime sort of thing.
Yeah.
Webinar Wednesdays at GSI, we can get that. There's no time in your curriculum, let's face it, to put yet another thing to learn. So you're going to have to be a lifetime learner. And geosynthetics, is it availing itself to that? YouTube, this is amazing to me.
Right.
And it'll be kept, and you'll be able to morph it into and expand on it sometime later. It's archived.
Yes, it's always evolving.
ASCE, that Brad was on the phone just a little bit before, and fantastic. How can you? It's going to be a hybrid system. You're going to keep doing this. It's really we're into Brave New World. This is really just going to be, and you're going to have to keep on it. You're going to get into a specialty, and then you're going to change job and learn in others. You're not going to be pigeonholed. This is an opportunity. This is the time to be an engineer.
It truly is.
Really.
Yeah.
If you have a background as a technical problem solver, you have work. It's really fun.
Yeah, one of the things I always often talk about with my students is, we're simultaneously pushing more to kind of computerized, codified designs in certain aspects of civil engineering. I think geotechnical engineering has been spared some excessive codifying, but it's that human component, that the judgment and the innovation and the problem solving, as you said, that that's not going anywhere. In fact, it's going to be in higher demand because that's the part of the design process we can't offload to software. So
but even you superimpose it with Bob Backus gives a lecture on big data and all that sort of stuff. That's just more. You have Alan Marr from the field, he's giving you the instrumentation piece, and you're coupling, it used to take everybody in the room to do one point to, calculate, slope instability. Now you do 4 different methods within seconds once you have the coordinates in. It's wild. It's just, you should force everybody to do it longhand once.
Oh, believe me. I hope there are a couple of my students from my slope stability class watching us right now, because we've done a few fairly manual slope stability analyses using spreadsheet methods, and they'll analyze one surface, and I'm like, and now we're going to have a computer program analyze 200,000 surfaces in the time it takes you to hit the enter.
The ISOs, and you used to boo the guy that got the you could tell he was off, or her was off. It was like, oh no, you're ruining our. And they give it. It's just totally changed.
Nice. So look, we're coming up on the hour, and I want to ask you just one more question. I think we can squeeze this in. I want to just throw out what's new and what's next. What is a product that's on the horizon? What's an application that's on the horizon that you're really excited about?
The composites will be it. These are multi-layered systems with ease of installation. These are on the horizon in a big way, from barrier systems to drainage materials. They're even smart. We just learned about one the other day of a very thin film that's electrically conductive that can be used in a myriad of applications, and even placed in a roadway to de-ice it. It just but the composites for ease of installation, and that would be there are clever people in there as well that will make connections, and unfortunately geosynthetics are a little tricky. If you don't install them perfect and they're not checked, they can lead to problems, and they're not fixed well with Band-Aids. It's good when they're done, installed correctly from the beginning. And there are people that make fasteners and connections that are pretty slick as well. But composites and then those little connections would be my two.
All right. So that's where we're gonna put our money in the future.
Don't do that. I'm not. No.
Well, George, this has been great. This was a lot of fun, and I hope the audience enjoyed this. I think we covered a lot of ground. I
have to stop you just for a second.
Yeah.
The GeoStrata contributors and the folks that my family, my heart's with you. This means a lot to me personally. That will be a keepsake for me. Just Dr. Withiam, all your editing, and Mike, Dr. McGuire, all your stuff. Thank you so much. I'm beholden to you is what I wanted to say.
Absolutely. I would also encourage anyone who's watching this right now, go check out the September-October issue of GeoStrata from 2014. Maybe that's on your bookshelf, or it might be available online. That's the Geo Legends article that actually my students at Lafayette College worked on for Dr. Robert Koerner. So I would want people to go and check that out again. But Dr. George Koerner, this has been great. I want to thank you for giving your time this afternoon, and I also want to again thank our sponsors, Aero Aggregates today, and thank you, Brad, for getting us kicked off. And I'm going to now hand it back to you.
Thanks, Mike, and thanks, George, and thanks, Mike, for doing such a great job today. That was a fantastic interview. I think to hear the joy in your voice, George, when you talk about geosynthetics is incredible. And I would like to say to those people in Reader's Digest or whatever it was who voted geotechnical engineering the most boring occupation in America for all those years, come talk to George and he'll pump some joy into you and some happiness and make you excited about it. So that was great. We really enjoyed that. And Mike did a good job giving a couple shout outs to our sponsor, Aero Aggregates. And I've got a little read from them. Aero Aggregates of North America produces ultra lightweight foamed glass aggregate from 100% recycled glass. It has a dry bulk density of 15 pounds per cubic foot, high friction angle, and is DOT approved. The glass aggregate has a closed cell structure which will not absorb moisture and provides long-term durability. You can learn more at aeroaggregates.org. Aero Aggregates is also an organizational member of the Geo-Institute. If you or your company would like to become one, you can find out more at geo-institute.org. Again, if you liked what you saw today, and I hope you did, it was really fun, click on the subscribe button, click get notifications, and you will know every time we post a new video to the YouTube channel. One reminder, it is, of course, our 25th anniversary. We hope you have made your contribution to the Student Participation Fund. If you have not, get on over to geoinstitute.org, click where it says Student Participation Fund in the menu bar. $25 contribution for our 25th anniversary gets you one of these handsome 25th anniversary pins. There are other gifts as well. And one final reminder that tomorrow on Director's Cut, our weekly show, you can see the interview with Geo legend Del Fredland and his son Murray. Should be a good one. They are great storytellers. Yeah. So thanks again, George and Mike, for doing this today. We really appreciate it. Thanks to our viewers for their great questions, and we will see everybody soon.
Thank you, Brad. Thank you,
Thanks,
Mike.
Brad.
Take care now.